One of the things that I find most fascinating about Hutchinson's legacy is that he and his students studied systems like Lindsley Pond and the lakes around Connecticut for decades. Many of those papers are forgotten at this point. Many of the early empirical papers were important but not profound. Yet they served as the inspiration for Hutchinson's truly remarkable work. So his synthetic work, the work that we still remember today, papers like The Paradox of the Plankton, came out of his deep understanding of these empirical systems, whether these were lakes in Nepal, whether these were lakes in Connecticut, whether these crickets, water bugs, you name it. He was interested in that, and that informed him in a way that allowed his true gift of synthesis to emerge.
Another great example that Hutchinson doesn't get enough credit for is the idea that systems don't achieve some happy balance. This idea of balance of nature may be misplaced, and that in fact these systems are non-equilibrium inherently. He has a wonderful paper from 1961 called The Paradox of the Plankton that was really based on his observations at Lindsley Pond, showing that these ponds never settle down, and one species doesn't just conquer the rest in the plankton and sit there. They're constantly chasing seasonal change. And Hutchinson used his observations over many years to reach the conclusion that there is no single equilibrium point at which one species can dominate. He is best remembered for his ideas about equilibrium concepts in ecology, including niche theory, the basic niche theory. But in fact, he himself moved on from those ideas, and those ideas remain the foundation of much of modern ecology. The idea that there is a lack of equilibrium, that change is not only typical, but maybe fundamental to these systems, is a dominant paradigm today that really, if you trace it back, owes much to what Hutchinson was doing.
One of Hutchinson's great gifts was that breadth. He had interests that ranged from evolution to ecosystem ecology, and he gave rise to those fields, but he saw them as that integrated part, and therefore he understood things like cultural eutrophication, pollution of lakes, aquatic systems by phosphorus, and he understood the impacts that those would have in a very broad sense, not in a very narrow sense that many scholars have worked on it. But he understood it could drive evolution, it could drive communities, it could drive ecosystems. He understood that climate could have these multifaceted impacts on ecosystems. One of the things that I love about that perspective that Hutchinson brings is that it's still valid today. It was valid in the 50s and 60s when he was doing work that created the very origin of a lot of fields in ecology and evolutionary biology, but it's still equally valid today as we start to wrap those fields back around on themselves. And really that's the only way we're going to address the ecological and the evolutionary effects of climate change, is to look at the effects of climate on nutrient cycling, on community organization, on evolution. All of those will play out at the same time, and Hutchinson's skill at bringing that together was really important.